892 words within range. Here's the final script. Right now, Boyajian's star is still flickering, dimming and brightening in patterns no one can predict, and Harvard has no way to stop it, or explain it, or even tell you what's causing it. This star sits 1,470 light-years away, and what its light is doing right now is something scientists cannot reproduce with any known object in the universe. But here's what nobody is telling you. The leading theory isn't a planet. It isn't a comet. It's something else entirely, and they're not ready to say it out loud. Astronomers call it KIC 8,462,852. You know it as Boyajian's star, named for the researcher who first flagged it. It's an ordinary-looking F-type star, slightly hotter and brighter than our sun, sitting quietly in the constellation Cygnus. Nothing about it should stand out. Nothing about it should make headlines. But in 2015, volunteers combing through data from the Kepler space telescope noticed something impossible. The star's light was dropping, not by a fraction of a percent like a planet crossing in front of it. It was dropping by 20%, then 22%, or the light of 1,000 Earth-sized planets blocking the star all at once. Nothing that large should exist that close to a star. And yet, there it was in the data, undeniable. Kepler had stared at 500,000 stars. Only one of them did this. Here's the anomaly that broke the models. A planet transit is clean, predictable, periodic. Boyajian's star does not behave that way. Its dimming events are irregular, days long, sometimes weeks, with no fixed schedule, no fixed depth, no fixed shape. One dip looked like a fleet of objects passing in a staggered line. Another looked like a slow, asymmetrical fade with no clear edge at all. Astronomers ran every simulation they had. A single planet couldn't do it. A ring system couldn't do it. Nothing in the standard planetary playbook produced a light curve like this one. And the deeper they looked, the stranger it got, because this star wasn't just dimming. Over the past century, according to old photographic plates dating back to 1890, it had also dimmed gradually by nearly 20% overall. Slowly, steadily, for over 100 years. So the obvious explanation, a shattered comet, a field of asteroid debris, should have solved it, except it didn't. A comet swarm large enough to block 20% of a star's light would have to be almost unimaginably massive, and it would glow brightly in infrared as it heated up and shed dust. Astronomers pointed the Spitzer space telescope at Boyajian's star, hunting for that infrared glow. They found almost none. Whatever is blocking the light isn't dusty debris. It isn't warm. It's something else, something that swallows starlight without heating up the way rock and ice should. And that single missing signature is why, for the first time in modern astronomy, a serious peer-reviewed paper proposed that the dimming could be caused by a megastructure, an artificial construction built by an advanced civilization harvesting the star's energy. Harvard's own Avi Loeb co-authored the idea, not a fringe blogger, a Harvard astrophysicist in a peer-reviewed journal. Now here's the strange part, the part that should not be possible at all. In 2017, astronomers caught the star dimming in real-time live for the first time. Telescopes around the world turned towards Cygnus and watched the light drop, event after event, for months. And what they found made things worse, not better. The dips were wavelength-dependent. Blue light dimmed more than red light. That's the signature of tiny dust particles, not a solid object, not a megastructure, not a planet. It ruled out an alien construction. But it created a new problem nobody could answer. What kind of dust cloud produces dips this deep, this irregular, and this repeatable without ever fully dissipating for over a century? No natural process astronomers know of should be able to sustain that. The dust should scatter. The star should stabilize. It hasn't. It's still happening right now while you watch this. This matters more than one strange star. If Boyajian's star really is surrounded by an unexplained cloud of fine, dark material that has persisted for a century without dispersing, it means there's a category of object in the universe that doesn't fit our models of how planets, comets, or debris disks behave. And if that same kind of object exists around other stars, hidden in plain sight in data astronomers have already collected, then some of what we've labeled as instrument error or noise for decades might actually be exactly this. The same thing, happening elsewhere, unnoticed. Every telescope built to hunt for alien technology, every survey designed to find another Earth, has been quietly filtering out signals like this one as junk, and nobody has gone back to check. So the dimming continues. The dust, or whatever it is, hasn't cleared in over 100 years, and nobody at Harvard, Yale, or NASA can tell you why, or when it will stop, or what happens if it doesn't. What is actually orbiting Boyajian star? Nobody knows. Tell us what you think is out there in the comments.